It's amazing, isn't it? Awesome. So this is a really cool way to demonstrate how two unequal weights interact with each other. So what is actually happening here is we have a large weight and we have a small weight here. That large weight is 572 grams, which is slightly above than half a kilogram, and this small weight is 46 grams, just 46 grams. So the ratio between these two weights is about 12.4. So having this ratio between these two weights, what I do is I tie these two weights with this thread. This is a normal thread, and I hold this is an iron stand, and I hold this contraption like this, the thread over this iron bar. This is a part of this iron stand, by the way. This is, and I hold it like this. I hold this smaller weight in my hand, and I hold the larger weight above my very precious mirror. So I hold this like this, and I give it slight angle, not exactly at the middle, but at the slight angle of it, slightly at the right. So if nothing will happen, this weight just fall down. This weight just falls down, and it will touches the surface of this glass and can break it. So I don't want this. We saw previously what it did. So instead, I want this small weight to protect this glass. So how it will protect it? I hold this contraption like this, and I give it a slight angle to it, and then I release it. So when I release it, what is actually happening here is the larger weight will fall down by the action of gravity, and this smaller weight will somehow wrap itself up with this iron bar. So the motion of this small weight is really complex. As this larger weight moves down, the smaller weight is actually wrapping itself up and shortening in length, shortening it in length, and the force of friction between this rope and this iron bar will keep it there, will keep this larger weight there, so it is not further falling. So no matter how vigorously, how dangerously I pull it, there's no chance that this contraption can move, because of the friction between the rope and the iron bar. The smaller weight is actually supporting a larger weight. So this demonstration reflects many scientific topics involving gravity, centripetal force, angular momentum, and friction. Friction is acting between the iron bar and the rope, and you can see that a really big weight is supported by the really smaller weight. You already know the values. So what is actually holding it there? That's friction. That's skin friction. And it is really amazing. If you want to perform this demonstration by with anything else. For example, you don't have this weight and you don't have this weight. This demonstration will work as long as the ratio between these two weights is maintained from 10 to 14. So when this ratio is 10, the difference between these two weights is not really large, and the weight may end up here. So it will end here. Not really amazing. So you need a weight which is really bigger, about 14 times bigger than this. So if the ratio is maintained at 14, the weight will stop there. Really amazing to say. So this demonstration will work as long as the ratio is maintained from 10 to 14. So I have here another contraption. This time the precious thing, which is the glass, is not a piece of glass, it's a cup. And this is a cup. I tied these two. This is the weight, by the way. It's a slightly smaller bob than this, slightly smaller. And what I do is I hold this contraption, in this case this contraption, over this piece of wood, the wood bar. So what I do is now if the cup falls down, I'll never get it back. So the larger weight, in this case this cup, will fall down and the smaller weight will catch it. Here's the thing which you can try. Take your friend's mobile phone and ask him this one question: do you believe in science? If he says no, then release it.